Good morning, friends. Let us discuss product building and structures, the part 2, that is model number 5. The first topic is analyzing virtual product models. So, virtual product models, so that already we have discussed what you mean by virtual product, but it is to be analyzed before going to a physical one. The products are designed and developed to perform their intended function in a specific environment. However, many simultaneous physical forces and phenomena impact product behavior. It is difficult to build complex physical prototypes and conduct experiments to predict its function in the real world environment. So as you know that to build the physical prototypes, it is a somewhat complex and you have to conduct experiments on that. Okay, after if it is a destroyed type of experiment, that's what once again you have to build a prototype. So it is a difficult one. CAE, computer aided engineering, to describe the use of computer software in the product engineering process from design and virtual testing with the sophisticated algorithms to the planning of a manufacturing. The CAD is used to create a geometrical product representation within a virtual environment. Then CA allows a deeper analysis of the product. So that is computer aided engineering. So it is its application in engineering fields like fluid dynamics, kinematics, stress analysis, then FEA, etc. Throughout the virtual development cycle, CAD and CAE go hand in hand. CAE helps to reduce the number of physical prototypes and experiments and optimize components in their design phase to develop better products and faster. There are various methods to evaluate product design. So in the next topics we will discuss the different methods utilizing in a CAE analysis. So as already you are aware of this, finite element analysis, computational fluid dynamics, and multi-body simulations. So what are these in brief? So we will discuss it. The FEA is the simulation of a given product or any given physical phenomenon using a numerical technique called finite element method. The technique is used to calculate stress, deformation, thermal load, structural dynamics, and NVH. NVH means noise, vibration, and hardness. So these things, so you can calculate it very easily in a FEA and predict the behavior of the product in the real physical environment. For example, a sitting chair can be analyzed for a stress distribution to identify critical location of a failure and the maximum safe load it can support in order to avoid a failure. So already you have studied this FEA, this particular software, so you know better. The potential issue thus identified and analyzed by FEA helps design engineers to review and optimize the design at an early stage, thereby saving time, energy, and money involved in developing the product. Various software tools like CATIA, Hypermesh, ANSYS, etc. are used for this purpose. So first you have to build that particular model in these softwares, and you have to go for the FEA software here. So you can analyze it. Suppose if you build a physical product and you test it, so it is a somewhat difficult procedure it is. So instead of this, you do it virtually, so you can save your time and money and also the energy. FEA works by discretization, that is breaking down a large structure with a high degree of physical complexities and mathematical discontinuous into a smaller, more manageable sections. Each section represents the material properties of a local domain. The mathematical model or geometrical model extracted from 3D CAD model is discretized by the finite element method, resulting in corresponding numerical methods. So like that, the boundary condition of loads, example forces, moments, then restraints, bearings, fixed parts, material characteristics, temperature, and other factors are defined directly in the FEA program. Designers can run simulation with the various components, designs, and compare outputs in a short span of a time, thereby eliminating the need for complex testing and analysis using a physical prototypes. So the how you can utilize this FEA and how you can save your time, energy, and money over here. So next, computational fluid dynamics. So what does it mean? Predicting the behavior of product working under extreme environments like a liquid or a gas flow, heating or cooling, chemical reactions, turbulence, and other related physical phenomena has always been challenging task for product designers and analysis. So as you know, there are some gases and liquids. Okay, then there are chemical reactions, then there is a large turbulence, so these are very difficult to analysis. The computational fluid dynamics, briefly abbreviated CFD, is in term used to refer a wide spectrum of numerical methods used for virtual analyzing and predicting complex 3D time independent flow phenomena related to products. For example, simulating and analyzing the flow of gas over the turbine blades. Okay, is taken a one simple example here, that is a turbine blades, that flow of gas, it is over that. Temperature distribution in a heat exchanger, it is a one more example. The analysis approach in this regard is similar to the finite element analysis only, except the software used being a different. The method is a same, but the software here they are using a different one. The data transfer from 3D CAD model into the CFD program is performed by neutral standard data formats. So example, that is a STEP and IGS formats. And the boundary conditions for the calculation are defined directly in the CFD program. Solvers like CFX, Fluent, Nastran, etc. are a few software used to conduct this type of analysis here. So it is this particular software, so only you can use it for liquid gas flow, heating and cooling, chemical reaction. So this is not possible in a FE analysis. Now last one, the multi-body simulation, that in terms so abbreviated, so it is a MBS. Multi-body simulation is a computer tool with which multi-body. So multi-body means what? Multi-body system is a system in which one or more bodies are connected to each other with the joints. Multi-body systems can be simulated using a computerized methods, that is MBS models are based on general geometrical definition in a CAD product structures. They consist of a stiff bodies or a mass points which are connected with each other or the environment by joints, that is a kinematic constraints, and or by specific force laws, and particularly for the low frequency range of motions. The body conditions, for example, force, torsional moments, masses, moments of inertia, degrees of freedom of a moments are defined directly in a MBBS program. The separation of the locally distributed parameters into discrete parameters. Example, mass, inertia, stiffness, damping leads to the physical discretization of the product model. Besides, the rigid consideration of a kinetic systems, elastic subbodies from FEM modeling can be imported and integrated to a demand. So how if it is a multi-body, so there you have to go for the MBS, that is a multi-body simulations. So example, in the boundary condition you have to consider, that is a forces, torsional moments, masses, etc. here. Okay, so next the topic, so we'll discuss the product planning and control. So in short, you can call it as a PPC. PPC includes the administration and organization of manufacturing relevant data and procedures. The released product data are transferred into the production planning process. PPC data are organized in a BOM. BOM is nothing bill of material structures and based on a 3D CAD geometry and a 2D drawings. The two important influences factors are working schedule and manufacturing resources. These are the main two factors under this, that is a PPC. Firstly, the basic economic and operational functions of PPC include the management of a customer's project calculations, planning of requirements, etc. So next one, second one, the PPC covers production control related tasks such as production management and control, controlling processes regarding time, quality and a cost here. PPC covers the economic and operational tasks of a manufacturing. The CAD/CAM operations basically handle technical functions here. The working fields of CAD/CAM can also be divided into two categories here. The first group includes planning processes such as product concept development, design and simulation, process planning, material logistics, and the programming of production machines and resources. And other second one in this group includes the control of manufacturing and quality management related procedures. This also includes the control of NC machines, transportation control, storage management, assembly control, maintenance management and quality management. So this is how this particular PPC it can help. So you can plan it very easily, and this is also you have to do it virtually here. Okay, so with this all there is a BOM structure, so it helps a lot. Then single BOM, that is a bill of material, the same BOM, so you can use it for the other department here. So like that, so you can have the proper planning over here. So next that is a product data technology. So product data technology, it includes all aspects of definition and methods of processing of data information related to a product throughout its development and operational life cycle. The management of all data in this data flow, processes and documents during the development or modification of products across the product life cycle provides the basis for an efficient virtual product generation. So it can be classified into a different categories, that is a product defining data. So it relates to the technical requirements that include all kinds of data for product specifications. For example, in case of automotive product development, the data can be related to driving performance, car weight, fuel consumption, dimensions, targeted vehicle configuration and other factors. Is taken one simple example of a automotive product. So next one is product described data relates. So what it says, it relates to the technical product documentation that include all the information that can be found in the bill of material list. It is. This is the second one, product describing data. That is a bill of material. So that actually you can at a glance, so you can have the total information about that particular product is. The third one, geometry data, relates to the CAD model files, styling data, geometry data, exchange formats, CAD based product structures and other design based data. Then next one, data information concerning the development process itself include workflow data, management of resources, data for engineering organization and others. This is what the geometry data it is, data information concerning data. So next we have the product configuration data. Product configuration data relates to the information about possible variants. For this we have examples. The data that define the set of the car in accordance with the customer orders, including the type of engine and transmission, safety features, colors and all possible accessories. Then last one, metadata, that describes additional product related facts such as production related information or data for calculation and organization. So here, to exchange of product data within the same software environment is mainly performed by the native data formats. While importing data from 3D CAD programs into FE simulation, software is accomplished with the use of neutral data formats. In case of product design and simulation related processes, neutral data formats provide product geometry data and limited additional product information for the exchange between different CAD software package or between CAD and CAE applications. So like this particular native data, so it can help in this the product data technology. So next, so we have a variant management. So what do you mean by this variant management? The customer accept and demand not just a product that meets the functional needs, but also one that is tailored to specifically meet their expectation. This includes style, color, special features and convenience of their choices. So for this, so we can have one simple example. The variants of motorbike may include a different style of design, color, features, etc. See, as you know, the customer so is not only accept that function, other than that how it looks, what should be the color and how it should be the structure and what are the other features. Okay, so these are comes under the variant management. So bikes were developed with the kick starting facility. So in olden days, so only that kick facility was provided in the vehicle, but nowadays so you can have a that is a starting with the starting expecting to have a power starting along with the kickstart facility. So this is what the customer expectation. Only if you provide the vehicle that is a power starting, but the maximum customer requirement is what? So that is power starting as well as a kick starting facility. Further, international markets which local particulars like people, rules and regulations often demand products in a different variants. Virtual management is a holistic approach to control and optimize product diversification with respect to the production cost and marketing strategy also. The key idea of virtual management is to optimize the number of product variants that can be manufactured while reducing the complexity of product development and manufacturing. The next, the production costs are typically kept low by manufacturing only a small amount of different models that common and recurring the multiple products. These models can then be manufactured in a large scales here. Variant management continues to be a critical consideration early in the product life cycle, especially as evolving design paradigms influences of product variants. So this is what the production management. And how to approach this variant management. So in the next topics we'll discuss in this session. Variant bill of materials is a critical aspect in the variant management approach. So as you know that bill of material, so this is the list, it is list of raw materials, sub assemblies, intermediate assemblies, sub components parts and the quantities of each needed to manufacture an end product. In certain instance it is referred as a product structure also. As already I told you that, so at a glance so you can have all the information related to that product. So managing is a distinct BOM for each variant of a product, and updating configuration as a product evolves is a time consuming and a tedious task it is. So for this, what they will do, the variant management makes use of a single BOM referred as a variant BOM for multiple variants of the same products. Okay, so here, so actually what is happening in the industries, for the different departments, they are having a different bill of material. So as per their convenient, they are going to make it. But the product life cycle in this particular, what it says, so you make a single BOM and referred as a variant BOM. So that means what? The same bill of materials so can be used for all the departments here. The various softwares tools are used to manage and support variant BOM. Stakeholders across the enterprise can interact with an accurate aligned 3D representation of the BOM without asking the designer or being CAD expert themselves. So already I told that if it is a single BOM, so without consulting anybody, so you can have all the details related to that product here. The data is automatically synchronized with the design, engineering and manufacturing tools. Because here we are using a software, so anything can be changed, so automatically, so it will be synchronized over there. This helps to optimize the number of product variant that can be manufactured, which in turn reduces the complexity of the product development. So like that, so you can approach this variant management. So with this I conclude today's session. Thank you.